Okay, let's go. Let's go to the next experiment. The next experiment is gonna be on momentum and energy conservation, right? These two quantities, momentum and energy, are important because these quantities are conserved. Means that the momentum or energy at the beginning of one interaction is equals to the momentum of energy at the end of the interactions. Well, of course, it depends on the type of interaction, the type of collisions, right? If we have a elastic collision, momentum and energy are conserved. If we have inelastic collision, only momentum is conserved. Okay, in this experiment, we are dealing with collisions, right? We have a projectile, right, hitting another object, and then after that, right, they move as a single piece, right, and they take some height from this level. So we're dealing with, at the beginning, with conservation of momentum, and later, right, with conservation of energy. Remember, how do we define momentum and energy? Well, we have that momentum by definition, right? Momentum is equals to m mass times velocity, right? Momentum is a vector, means that depends on the direction too. What about energy? Well, when we're dealing with conservation of energy, we're dealing with the total mechanical energy. And how do we define the total mechanical energy? Well, the symbol is E, right, equals to kinetic energy plus potential energy, right? Where kinetic is 1/2 mv squared, right? And potential is gonna be mgh, right? Or height, correct? Now let's use again these questions on this experiment, right? To find, in this case, height, right? This height at the end, right? And compare that height with the experiment. Okay, let's do it. To begin with, we need to find the initial velocity of the projectile, right? The bullet. Right. For this experiment, we are using this spring gun, right? It's a toy that I found in a store, right? So we have this spring gun. So we need first to find the initial velocity. Now we can find initial velocity in different ways. One way is gonna be this one. Okay, let's send, right, the projectile from here, right, to here in free fall, right, going straight up. So at the beginning we have initial velocity, at the end, at the maximum height, velocity is 0. Once we know this height, right, we can find it, okay, and we use one of the kinematic equations, like v final velocity square equals to initial velocity square plus 2g delta y. This is from kinematics, right? We can solve for initial velocity. Well, we know that the condition right here at the end is final velocity 0. So this is 0, and we have, right, at the end that the initial velocity is square root 2gh. Okay, h is given, plug it right here, and we can find the initial velocity, correct? Okay, that initial velocity is used for our experiment. Okay, let me erase this part for our experiment. Yes. Okay, now let's go first with momentum, right? We have the initial velocity, we have an object, right, moving, another object at rest, right? They hit and move, stick together and move as a single piece, right? This is a type of inelastic collision. So to solve that problem, we use conservation of momentum. Okay, let's do it. So we have initial velocity times the initial mass, right, equals to the total mass at the end, because they stick together, times the final velocity, right? This big M is just the sum of these two masses, right? Okay, perfect. Now we solve for final velocity. The velocity just after the impact, right, equals to m1 times v1 initial divided total mass. From this data, we can find the final velocity. Okay, now let's use that velocity for case 2 or 3 in this case. Okay, now we have an object, right? We have this mass, right, together, the bullet and the other mass right here, M1 and M2. Now they move, right, with initial velocity, and at the end we have final velocity equals to 0, right? In this case, we use conservation of mechanical energy. Means that the kinetic is converted into potential. Okay, great. Now, this is the equation, right? That says that kinetic energy is converted into potential energy. From here, we solve for height. Again, height is being provided in the experiment. Later, I'm gonna show you, right, how it works, right? And from the video, from the experiment, you're supposed to find this height and this height too, correct? So this is from the theory, right? This is from the analysis. We got this equation. The theoretical height is equals to v square, right? That v is this one, right? It's final velocity, which is this one right here, right? Which is this one from here. Perfect. The square divided by 2 times g. Okay, we get the value and compare that value to, right, that one that we found in the experiment, this one right here. Okay, after that, let's go to find the percent error, right? The percent error is just the theoretical quantity or standard quantity, or the true quantity minus the experimental one, absolute value, to avoid negative signs, right? Divided by the theoretical value. Some books divide this by the experimental. The idea is the same, right? Times 100%. Sometimes when we don't have a standard value like a G, right, theoretical value, which is taking as the average 9.80 meters per second square, usually we use right here the average of these two, right? But in this case, let's take it like that to find the percent error, right? Okay, now let's go to show you how to find this let's call this H what? H1, okay, for simplicity, H1, okay, H2 to differentiate them, right? And right here, this is H1, and right here is gonna be H2, right? H2, okay, H2. Great, perfect. And now let's label it in this way just to differentiate this H from this H, different H. Okay, perfect. Okay, next let's go to see how to calculate H1 and H2. Okay, see you in a minute. Okay, now let's go to find H1, right? I already have the centimeters right here from 140 to 162. So the bullet is gonna be coming, right? It reaches some height right from here and goes down. Please later you can zoom in, right, to find right the closest distance, right, or height that help us to find, right, H1. Let's do 5-6 trials, and then from this you're supposed to find an average, and that average is gonna be this H1. Okay, let's do it. So we have again different trials. Let's do the first one. Okay, okay, that's the work. Okay, the next one is coming. Okay, the next one. Okay, one more time, something happened right here. Okay, it's coming. Okay, this is trial 1, perfect. Let's work to the next one. Okay, okay, number 2, great. The next one is coming. Okay, the next one is coming. The next one is coming. Okay, looking for the bullet. I found it. Perfect. Okay, let's see. It's ready. Yes. Great. Okay, let's find the next one. The next trial. Okay. 2. Correct. One more because you're so happy. Okay, one more. Okay, perfect. One more is coming. Okay. I'm looking for the bullet again. I found it. I can't believe it. Okay, one more. Okay, let's see. You can get a good approximation. Okay, one more. Okay. Okay, perfect. Let's see. Okay, one more. Okay, Perfect. Now, hopefully with this is enough. You have 3 or 4 trials, right? Try to make an average to find H1. Now let's go to find H2. Okay, let's do it. Okay, let's go to find H2, this quantity right here. The same thing as we did for H1, right? We have this height in centimeters, right? These lines. Now let's use a the marble right here, and this extra mass. This is just Play-Doh, right? They're supposed to come in, right? Hit this, right, like an experimental ball, right? And go some height and go back, right? And that height is gonna be H2. Let's do 2 or 4 or 5 trials, right, as we did for H1. Okay, let's do it. So let's load the spring gun, right? Let's place the M2 right here, right? And let's hit it, right? Yeah, around there, right? You can see it goes from 0 to 19, correct? So it says trial 1. Let's go to one more. Perfect. Okay, the bullets right there. We have M2 right there, right? And let's do it. Okay, so more or less about the same height, right? One more time because you are so happy. Okay, let's try this one right here. One more time. Okay, okay, let's see what happens. Okay, a little bit more, like a 20, 21. Remember, the height is gonna be the center of mass, right? Right here, it goes right like that, right? Approx, right? The center right here, the center, right, of this mass. Okay, one more time. Perfect. Okay, let's remove the marble right here, put right inside, correct. Okay, one more time. Let's see, where is it? Okay, saw it. Okay, right there. Okay, let's do it. It didn't work. Okay, one more time, one more time. Okay, great. Okay, let's see, this one works. Perfect. Okay, let's do it. Perfect. We have 3 already. Let's go for the last one. Correct. Okay, let's load the spring gun. Great. All right, now let's do it. Okay, so we can have an average right here, more or less, and let's use that as H2. Compare that with the theoretical value, right, which is this one from this formula right here, right, and find the percent error. For masses are given on the top. Well, let me write right here one more time. M1, right, is equals to 5 grams, and M2 is equals to 9 grams. Okay, these are the masses. This is M1, right, and this is M2, right? M2 and M1, correct? These are the masses, right, that we're supposed to use in the equation. Okay, perfect. And with this, we finish this beautiful experiment. It's a homemade experiment. You can do at home too and see how exciting it is. Okay, see you in the next experiment. Bye.